rocking the cannons again. Fire away! This one's for the motherland. Alright, guys. This is for Alright, one more time. We're sending them home with this one. Fire away!
In this video, the first thing we did was list the values that we will use to calculate the initial velocity. Using a ruler, we found that the height of the mallet is 0.23 centimeters and the height of the rod is 0.20 centimeters. Using a triple beam balance, we found two masses. The first mass is the mass of the marble, denoted by little m, which is 0.013 kilograms. The second mass is the mass of the marble and mallet system, denoted by big M, which is 0.0474 kilograms. We first will calculate the velocity from the second position. To do this, we found that theta equals 19 degrees, so theta will be used to find the difference in height. Let cosine of 19 equal x over 0.20, which is the height of the rod. Once we found x, which is 0.189, we will subtract x from 0.23, the height of the mallet. This gives us a value of 0.041 centimeters for the difference in height. We know that during the collision, the marble has kinetic energy. We also know that after swinging up to a stop, the kinetic energy is turned into gravitational potential energy. Therefore, we can set potential energy equal to kinetic energy. So the mass of the system times 9.8 times delta H equals 1/2 times the mass of the system times velocity prime squared. After plugging in these values, we find that V prime equals 0.895 meters per second. The last step is to set MV equal to MV prime. So we plugged in the value of just the mass of the marble times V equals to the mass of the system, 0.0474 times 0.895, which we calculated previously. And then we find that the velocity equals 3.26 meters per second. So that's the final answer. Using the same method, we calculated the velocity from the third position. So theta in this case equals 22 degrees. Using that, we calculated x and then subtracted it again from 0.23 to get 0.045. And then we set kinetic energy equal to potential energy and found velocity prime. And then after that, we set MV equal to MV prime, and then we found the final answer, which is 3.42 meters per second. And that's the velocity that the marble was fired at initially.